Hello, my dear student. Welcome back to my YouTube channel. Am I audible and visible to all of you? Am I audible and visible to all of you? One second. Okay. One second. Good evening. Good evening. Good evening. Okay, I guess there is some sort of issue, no? Okay. So homework, right? There's some issue. No issue. Okay, so first of all, we will discuss the homework numericals that I had given in the last class. Yes, I will. We will be discussing it now. Okay. One second. We will discuss your homework numericals. Let me check. First of all, your homework numericals. I don't know, right? I need to check your homework firstly. Then we will start. I don't have any idea now. So we can do one thing, no? One second. Wheatstone bridge. Okay. So let us start. In between, if you find any doubts, you can just let me know. Okay. I guess my screen is visible to all of you. I guess my screen is visible to all of you. Let me know, right? And in 2 or 3 lectures, we will complete the electrostatic. Then we will start capacitor. So I have given you some numericals homework, right? Okay, this one is homework. This numerical is your homework. I hope that you have got the answer for this one, no? Look now. So how we can deal with this numerical type? Look here. How we need to deal with it. Look. So if you can see, no, potential of this point is A, potential of this point is B. So let us take this point as C. This point as C, D, then E. How many points we have? So we have A, C, D, B, E. So I will write here A point. This one is B. I will write here C. Then any point D, right? Then let us AC. First of all, this one is between AC. So I will make it between AC. 6 ohm. This one is between C and D. C and D. Look. 3 ohm. This one is between D and B. D and B. 7 ohm. This one is between. So there is common point. Now look, there is common point E. Okay. There is common point E. So A is connected with E. So that's if So if A is connected with E, no? E, D, so D we have 3, so let's suppose we have any E now. If this one is E, no? So AE here 8 ohm, AE, then CE, CE, how much? CE 10 ohm, then we have DE, DE 4 ohm. Okay, okay, so you can see here now, you can see here, look here, 6 by 8, I can write 6 by 8, then 3 by 4, 3 by 4. You can look how you need to make it now, how you need to make it, look now. You have to take 2 pointers, A and B, okay? Now make these A and B in this way, then C and D in this way, right? C and D in this way. Then you have to make the diagrams, no? Now look now, you can see it now, no? You can see it now. This by this ratio equals to this by this ratio. How, sir? Look, 2 3s are 6, 2 4s are 8. I guess 3 by 4, 3 by 4. Yes, sir. It is a condition of Wheatstone bridge. Balanced Wheatstone bridge. So you can take this one out now. There is no fun of writing this one now. Okay. Now look, this 6 and 3, these are in series. So R equivalent came out to be 9 ohm. 8 and 4 in series, R equivalent came out to be 12 ohm. Now this 9 and this 12 is in parallel. So how you need to write it now? It will take time, no? So you need to make it now like this. Look now. B, A. This one is 9 ohm. This one is 12 ohm. This one is 7 ohm. And these two are in what? Parallel. So you were right. R equivalent came out to be 9 into 12 divided by 9 plus 12. Done? So what is 9 into 12? 9 to the 18. 18. It is 108 divided by 9 plus it will 21. Done now? Okay. Now 108 divided by 21, I guess it is 5. Yes. So now make one more diagram. This one is 5 ohm. This one is 7 ohm. Done. So R equivalent came out to be 12 ohm. Yes. This is my required answer. Easy, tough? Easy or tough? Easy, no? Okay. This one is easy now. Moving towards second numerical. Second numerical. This is my second numerical. Look, you can see here, no? Look, beta. If you, this is A point, this is B point. I will take this A point now, I will stretch it now. Okay, it is like this now. I will take these two strips A and B and I will stretch it like this. And now you can clearly see now, look, it will become now, it will become now 1, then 1, one more, one more. Okay, it will become now like this. My A is in this way, B is in this way. So this is a clear case of balancing. So there is no usage of this one. So my R equivalent came out to be, look, R plus R, 2R. R plus R, 2R. This two R is what? Parallel. So you will write what? 2R into 2R divided by 2R plus 2R. It is 4R square divided by 4R. 4 cancel out, R cancel out. My answer is R. Okay. This is how you need to do your numericals, no? one more. This one now. This is a case of extension of Wheatstone bridge. This one is an extension of Wheatstone bridge. Sir, how we will just define it as, look now. What is the ratio of 10 by 2? 10 by 20? Sir, ratio will be 1 by 2. What is the ratio of 20 by 40? Sir, ratio is 1 by 2. What is the ratio of 30 by 60? Sir, ratio is 1 by 2. You can see now, ratios are same. So there is no usage of these two things. So if you need to make redraw it, so it will become 10 plus 20 plus 30, 60. It is 60 ohm. Then 60 plus 40, 100, 120. So here we have what? 120. 120 and 60, these are in what? Parallel. So you will get 120 into 60 divided by 120 plus 60. Okay. And this is your answer. You can just do this one now and you will get your answer. Done? This one is interesting now. This one is interesting. What's it? 10, you will have how 10 identical cells connected in series are needed to heat a wire of length 1 meter. It states that this one is good now. Look how we have 10 identical cells, right? How many cells we have now? This one is a very good numerical now. You need to pay attention to this numerical now. One second, beta. So how many cells we have? 10. We have 10. 1 to up to so on to 10. 10 numericals. And we are having 1 meter rod, something like that. No? It is resistance is R, length is 1 meter, and resistor is radius is R. And these are identical, so EMF is E, radius is R. Done. And cells are given as N is 10. 10. Now, if we change the length of this part as 2m, now length was firstly, initial length was m, 1m, final length is 2m. Now, if we are just heating this particular thing and delta T is given as 10 degrees centigrade in time T. If we want to heat the same material is same, radius is same, area is same, length is different. Now, if we want to heat this one to same temperature, what should be the number of cells? So how we can get it? Look now. For this first part where N is 10, heat is involved. You can see now, heat is involved. Yes, sir, heat is involved. So I guess from 11th standard, you know one equation, delta theta, heat change equals to ms delta T. You will write it for first one, right? First one. Now for second one, same, delta theta 2 equals to m2s delta T. Sir, let us take the ratio of these two, no? Ratio of these two. Look, if we will take ratio, no? So what we will be having? We have delta theta 1 by delta theta 2 equals to m1s delta T divided by m2s delta T. Same temperature, s cancel out. So what we have now? We have this particular equation. This is good numerical. We are merging 11th and 12th topic. Look now. So my equation came out to be delta theta 1 divided by delta theta 2 equals to mass of first one divided by mass of second. Sir, how to find mass of first and second one? For that thing, we have one relation, that means density. Density equals to mass by volume. So you will write mass is equals to density into volume. Volume is area into length. Density is same, area is same. That means mass is directly proportional to length. Now, in second case, my length is 2L. That simply indicates my mass will be 2m. So I will write delta theta 1 divided by delta theta 2. Mass of first one is m, mass of second one is 2m. Cancel out. So I will write delta theta 2 equals to 2 times delta theta. Done? Okay, now what is delta theta, sir? It is heat, energy, no? And what is the formula of energy? Do you know it? Sir, energy equals to I square into R into T, or you will write V square divided by R into T. You can write like this. Okay. For first one, delta theta for first one, you will write what? Sir, V square. It is E square divided by first one is R. So you will write R. Done, no? And you can write N square E square divided by R into T. For first one, done. Second one, delta theta 2. So what I can write here, I will write N1 square. It is N1 square E square divided by radius. Radius is 2R. So I will write 2R into T. Done, no? Take it is ratio. Look now. R cancel out, T cancel out, E square cancel out. So I will write here delta theta 2. So don't do one thing now. Do one thing. Don't cancel anything here. Don't cancel anything. Don't cancel anything here. I will don't take a ratio also. Delta theta 2 is N1 square E square divided by 2R into T. 2 times it would be N square E square divided by R into T. T cancel out, R cancel out, E square cancel out. Then we have N1 square equals to 4N square. N1 square equals to 4. What is N? N is 10 square. So N1 square is 400. N1 came out to be 20. Okay. Good numerical, no? I guess this is something different, no? We are just manipulating values from 11th thermal physics to the electric current also. If you have any doubt regarding this one, you can just let me know right now. Huh? If you have any doubts about this one, you can just let me know. You need to do some numericals, no? That means hardcore numericals. You have to do some hardcore numericals from your studies, okay? So that you will get some sort of confidence how to manipulate your numericals now. Then we started meter bridge, and after that I have given you this one, these two, right? Okay. So this one, how to do this one now? This numerical, how we can get it? This numerical. Last time I told you current through this one will be 0. So if we use KVL, what is the potential? Current I is going through this, no? So what is the equation you will write now? Huh? Which equation you will write now here? Look, if you go minus to plus, you will write plus. It is plus 10. Then it is minus I into 10 equals to 0. So you will write 10 equals to 10 times I. I is 1 ampere. The current which is flowing through this circuit first it is 1 ampere. Done? The current flowing through this one now, through this one, what do you write now? You will write plus 4. Then it is plus 4. You will get from this to this one now, plus 4. Then what do you have? You will have minus I2 into 1. Then you will have minus 2. Then you will have here current will flow in this way. You are going same. It is minus I2 equals to 0. So look, 4 minus 2 is 2. I2 minus 2I2 equals to 0. So I2 is 1 ampere also. So we got I1 1 ampere, I2 1 ampere. Now look now. But what we have to study now? We have to find out Vp minus Vq. Let us take this path now. This path and this path. Look. I will write potential at P. Current is flow in this way. We are going opposite. So it will become positive. It is plus 10 times I. 10 times I, right? Okay. Now through this one no current is flowing, so you will write plus or plus 0 into 1 minus into positive, it is plus 5, right? If you're going in this way now, plus 5, then we are going in this way opposite to it, so it will become plus I2 into 1 equals to VQ. Now look, VP plus 10 plus 5 plus 1 equals to VQ. So VP minus VQ equals to 15, 16 now. Is it 16 now? Why are doing something wrong? Why is it coming then negative? Huh? I think we are doing something wrong, no, beta? If it is 10, positive, 0, that simply indicates now. So it just simply indicates that I will write VQ minus VP came out to be 16 volt. VQ is a higher potential. Done? Okay. Next numerical. This one is your next numerical. Okay. And I have given you some trick for it now. You can see it is unbalanced Wheatstone bridge. So how we need to do it now? Unbalanced Wheatstone bridge. So do it like this now. Look. Okay. We are not using KVL. That is a very lengthy one now. 10, 5, 5, 10. 10 and 10. First thing, don't consider any arm, right? So look now, 10 plus 5, 15, 15. So we have 15, 15. So my R equivalent for this is 15 by 2. Now my total R equivalent came out to be 15 by 2 plus 10. It is 15 by 2 plus 10. It will be 15 plus 20 by 2. It will be 35 by 2. Okay. Second one. Second one is, these are tricks now that I have given in the last class. These are some tricks, right? Look, beta. Connect these two. 10 volt, 10 ohm, 5, 10, 5, 10, right? So you can see now these two are in parallel, these two are in parallel. So what will be R equivalent for this one? Sir, my R equivalent came out to be, it is 5 into 10 divided by 5 plus 10. It will be 50 by 15. It will be 5 3s are 15, 5 10s are, it will be 10 by 3. 10 by 3 for this one, 10 by 3 for this one. So what will be R equivalent for both? Sir, it will be 10 by 3 plus 10 by 3. It will be 20 by 3, right? Now 20 by 3 plus 10. So what will be R equivalent now? Sorry, 20 by 3 plus 10. It will be 20 plus 30 by 3. That will be 50 by 3. So one answer is 50 by 3 and one answer is 35 by 2. Okay, so my R equivalent will be less than 50 by 3 but more than 35 by 2. There will be only one option between these two options. If you don't want this shortcut now, what you need to do now? You have to use KVL. You need to use KVL now for this loop, for this loop. Use KVL. There is no issue. Okay, you can use KVL. You will get your answer also, right? But this one is for unbalanced Wheatstone bridge. I have given you some short tricks by which you can do numericals for unbalanced. Look, in your examination, it is a very rare case that you will find any numerical based on unbalanced Wheatstone bridge. And most teachers doesn't teach these things, right? But why do we take any kind of risk now? We need to know now if this one is in the syllabus, so why not do some numerical based on this one? Yeah, for KVL it will be lengthy. Why? Look, what do you need to consider now? You will consider, sir, if I current is flowing through this one, then I1 is this one, so it will become I minus I1. Okay. Now here it will be, sir, I into G, so this will be I1 minus IG. Okay. Look, so you have one variable, you have two variables, you have three variables. So you need to do one, two, then you will take this one, three. So three variable, three equation, you can solve it, but that will be very lengthy. In examination, we know that we have hardly 1 or 2 minutes for lengthy questions, right? So we need to be depending on these short tricks. That's why I'm giving you some short trick also for these numericals. Okay, one more numerical. Okay, this is also an extension case. Extension case of Wheatstone bridge. Look, what you will see now. Look, if current I is flowing, sir, I will leave. Through this one, I1 is there. Through this one, I2. Through this one, I3. Okay. If look, 2 ohm, 2 ohm, R, 4R, 4R. First of all, we are seeing from this end. Secondly, we are seeing from this end. Okay. If we are seeing from this particular end, and if I1 current is going to 2R, then if we are seeing from this one, this same current should leave I1. Okay. If I2 current is going through R, from this perspective, this I2 current should leave your R. If I3 is going through 4R, that I3 should leave this 4R. By symmetry, that means no current will flow through these resistors. So you can see now, look now, 2R, 2R, 4R, 4R, R plus R, 2R, 4R, 4R, 8R, 8R. Done? All three are in what? Parallel. So what do we need to do now? I will write 1 by R equivalent equals to 1 over 4R plus 1 divided by R plus 1 divided by 8R. Done, no? I will do, first of all, now I will write not in this way. I will take 1 by 8R here, 1 plus 8R, then I will take 1 plus R. Is it R, 2R? No, it is 2R, no? Yeah, R, 2R, it's 2R. So I will take 1 by 2 common, then I have 1 by 2R plus 1 by 4R plus 1 by R. I will cross multiply now, 1 by 2. It will have 4R plus 2R divided by 4 to the 8, it will be 8R square plus 1 divided by R. So we have here 1 by 2, 6R into R plus 8R square divided by 8R into R square. Done? So R equivalent, I can write it equals to 16R square into R divided by 6RR plus 8R square. This is my answer. You have to do some numericals, no? Good numericals, right? You can do one thing now. Take R common. You can take R common. 1R cancel out, 1R cancel out, 1R cancel out. You can take like this. Look, and 2 4s are 8, 2 3s are 6, 2 8s are 16. So you will write 8RR divided by 3R plus 4R. You can either write in this format, no? It is up to you then. Which format you want to use, no? It is up to you then. Okay. The last homework question, right? This one. We know now. We know we need to by heart these results, but still I will give you now. Look, let's suppose we have battery E, current is going I. Now it is symmetry. Now if current is going I, it will divide in three parts. It is I by 3, I by 3. By symmetry, now I by 3. Now here, this I by 3 needs to go in two directions. So it will become I by 6, I by 6. Here it will become I by 6, then I by 6. I3, it will be I by 6. I by 6. Now I by 6 here, I by 6 here, it will become I by 3. I by 3. I by 6 is here, I by 6 is here, it will become I by 3. I by 6 is I by 6, it will become I by 3. I by 3, I by 3, I by 3. It will become what? I only. Yeah, this one is our NCRT, na? It is from NCRT. You can check, na? Now, we will take a shortcut path, na? Shortcut. So look, we will use KVL. We will go in this way, na? In this, look, we will go in this way. Look, now. We will take a path like this, na? Shortcut path. We will take this path. Okay? So how you will write this path now? If it is V, na, not V. V, na, in NCRT is V now. How will you will write now? So look, current is flowing in this way. We are going same in this way. So what will we write? We will write here, sir, this one, it is minus I by 3 into R. Then this one, minus I by 6 into R. This one, minus I by 3 into R. Done, then plus V equals to 0. I by 3, I by 3. 2 by 3, 2 by 3, 1 by 6. 5 by 6, it is minus 5 by 6 into R equals to V. Minus V. So V equals to 5 by 6 into R. Easy? This one is known as main diagonal. So the resistance of a main diagonal is how much? 5 by 6 times R. Easy, na? So these were some PYQs, and yesterday one student was there, na? Was asking, sir, what is the solution for these PYQs? Sorry, these numericals that I have given to you, right? So it's 11. Now we have a lot of time, right? Look, now we will start new topic now. So today we will start new topic. I guess you are doing some numericals from your NCRT and from your DPPs from any institute, right? In which you are enrolled now. Look, after attending the class, it is very much important that you will do some DPP, some module questions, NCRT, right? PYQs. So that will give you some sort of boost in your confidence. If I am giving some, look, it is not possible that each and every type of numerical I will be doing in class now. But most probable numericals I will be doing in classes. Yes, power. Look, today's class we will be doing power and heat. Okay, and tomorrow we will try to complete the chapter by tomorrow. Okay, because we want some pace and speed, no? So we will write what? Power and heating effect and heating effect of current. Done? Okay. Now if we are having a resistor here with 12 o'clock. If potential difference between the resistor is V, current I is flowing and resistance is R. So what I can write here, sir, my V is equals to, I will write here, look, sir, my V is equals to I times R. Ohm's law, na? Ohm's law. But one more scientist came into play known as Joule's. Okay, now Joule gave a statement that whenever current is flowing through any resistor, there will be a collision of the charged particles, due to which there will be a production of heat. Okay, so what Joule stated that if a charge is flowing through any resistor, due to the resistance property, charged particle will what? Get opposition. Due to that opposition, there will be a loss in energy in the form of heat. So you will write heat. Heat, right? Heat is an energy and it is equals to I square into R into T. Or you will write I. Look, what you will write I now from this equation, I is equals to V by R. So you will write it V square by R square into R into T. R cancel out, so my H came out to be V square by R into T. One formula, two formula. Done? Or look, we can write it in this way, V into V by R into T. What is V by R? So V by R is I. So you will write it what? VIT. That's Vellore Institute of Technology also, na? The famous in South India. So how many formulas you are having for heat calculations are I square into R into T, V square by R into T, and VIT. So these three formulas we can use for our numerical purpose. Okay, let us do some numericals now, some PYQ from IIT. Okay, let us do some numericals from IIT. We are having three resistors with equivalent resistance R, R, and R. Then let us connect these resistors in parallel. R, R, and third case now. Third case now. R, R, R. If current I is going through all of them, I. Okay. So tell me. Okay, one thing now I have not given you one thing, that is power. What is power now? I will write here power. Now what is power here? What is power here? Do you have any idea about power? I guess it is heat production by time. What is I? First is it is I square into R into T by T. Second one, it will be V square by R into T whole divided by T. Third one is VIT by T. T cancel out, T cancel out. So my power is equals to I square into R, 1, which is equals to V square by R. Third one is VI. Okay, so we have how many formulas? Sir, we have three formulas for power. No? Look, power, three formulas, heat, three formulas. Now here, look, if power is P1, here power is P2, power is P3, we need to find relation between P1, P2, P3. Okay, okay, sir. Look, if current is same now, if current is same, we need to get relation of resistance, right? So I can use this relation. Why, sir? Look, P is equals to I square into R. I is same, so you will write P is proportional to the R. More R, more power. So here R, R, R. So my R equivalent is how much? 3R. R, R, R. R equivalent is R by 3. R, R, that is R by 2. R by 2 plus R, it will be 3 by 2R. So you can see that, sir, P1 is more than P2, P2 is more than P3. Sorry, P3 is more than P2. Easy, no? Look, I am not going to explain you each detail of it, no? You are a grown-up child right now. You can manipulate these things now. Look, I have given you a couple of numerical in which I detailed calculate how is R equivalent 3R. How it is R by 3. How it is 3 by 2R. Now look, with the time passage, na, I am doing some calculation fast. Okay, in the same way you need to do it, no? You need to go from this to this one. If you are going from slow to the high one, look, you need to increase your pace. At the end, you need to write your examination, no? If you are not going to put some extra efforts from your end, you won't crack any examination in your life. You are in 12th now. Next time you will be writing your examination. So you should have some guts, no? Okay. In the same way, I am not giving you the definition of power. So what is power now? Okay. So define power, write the power. Why? You are in 12th right now. You have the books. I will tell the power is energy by time. Work by time, heat by time. Okay, you need to understand something, no, beta? If let us suppose I am writing each and every definition, then it will take a very so long time. It will take 1 year to complete the whole syllabus, and eventually you suffer, no? And I hope that you are studying from somewhere in school or in some institutions, right? You will get some module or some books from there also. You will get some extra from here, no? Extra numerical practice, extra thinking capability regarding your particular topics. That's why you can see, no? In my class, I am teaching you to the point. Nothing right or wrong. To the point. Okay? I know that this thing will come in the examination. So I'm teaching only those things now. According to the NCRT, according to the latest syllabus that is for your examination. Okay, now one more numerical, and this numerical will revise couple of topics. We have something like this. Current I is going inside and I will leave. This one is 1 ohm. This one is 3 ohm. This one is 8 ohm. Done. Power for 8 ohm, it is given as 2 watt. So you need to find power through 3 ohm. Look how you need to think, na beta. How you need to think to solve this one. Let's say I am seeing this numerical. So what thing needs to be get strike in mind, na? Sir, power. That means power. Power is equal to how much? Which equation I will use? Sir, power is I square into R. It is V square into R. Done? No, it is not V square into R. It is V square by R. Or it is V into I. These are some topics. Okay, sir. Now here, if I need power now, for power, R is given. R is given. That means I need to get V or I need to get I. V or I. Then I will you put the values and I will get my R value. Okay, so how I will get V or I? Look, I guess this one is given, so this is hint. This one is hint now given in my examination. Okay, how, sir? Look, what is power? Sir, power is equals to I square into R. Power is 2 watt. I square we don't know. R is 8. So I square is equals to how much? Sir, it will be 2 by 8. That means 1 by 4. So current I came out to be how much? 1 by 2 only. Okay. Sir, current is 1 by 2. So what will be the potential difference, sir, according to the Ohm's law? We don't know. I is 1 by 2. R is 8. 2 ones are 2. 2 fours are 8. So V came out to be 8 ohm. Sorry, 8 volt. So potential difference across these two is 8 volt. You will see now, look, potential difference is 8 volt. And you will see now, the same will be across this one. Why? Because in parallel, same potential drop, 8 volt and 8 volt. Then 8 volt, no, beta? No, 4 volt. Sorry, it is 4 volt. You are not telling me now. It is 4 volt. 4 volt and 4 volt. It is 4. Now, we have these resistors 1 ohm, 3 ohm. And V is given me how much? It is 4 volt. I need V1. I need V1. V1 across these two, now V1. So I guess I will use voltage division rule. I will use voltage division rule. Sir, what is voltage division rule? Well, look, same current will flow, na? So I will write, sir, V is equals to, it will be 3 divided by 3 plus 1 into 4. It will be 12 by 4. It is how much? 3 volt. That means potential across these is how much? 3 volt. And potential across this one is how much? 1 volt. Now, look, I will use V equals to IR. V is 3. We don't know R is 3. So I came out to be 1 ampere. So I can use any formula now, sir. How? P equals to I square into R. P, I is how much? It is 1 square into R is how much? 3. So P came out to be 3. Or I can use this formula now. V square by R. What is V3? It is 3 into 3 divided by 3. Look, my power came out to be 3 here also, right? I can use any formula. I will get 3 only. Huh? I can use any formula. I can get 3 only. Done? Now next numerical. Next numerical on the screen right now. Look now. Look. We have now system like this now. Yes. 10 volt, 5 ohm, then R. Power. Power is given to us, that is 30 watt. Power of system is given as 30 watt. Done? What will be the value of R? Okay. Sir, how to get it now? Value of R? You can see now, look, this R and these 5, these are in parallel. So you will write R equivalent is equals to R into 5 divided by R plus 5. Done? Yes, sir, done. R we know now. So which equation I will use now? Sir, we know that P is equals to I square into R, which is equals to V square by R. Look, P we know. Okay, V we know. Okay, R we know. What is P, sir? P is 30. V is 10. It is 10 into 10 whole divided by R. R is how much? It is 5R divided by R plus 5. Look, 1 0, 1 0 cancel out. 5 1 is 5, 5 2 is 10. So I will write 3 equals to 2 divided by 1 whole divided by R divided by R by 5. No, take it easy. Don't worry. 3 equals to 2 by 1 into R by 5 divided by R. 3 equals to, it will be 2R plus 5 to the 10 divided by R. 3R minus 2R equals to 10. So R equals to 10 ohm. R is 10 ohm. Why? Any issue, beta? Look, how we need to do numerical, how we need to think how to solve it. In question, it is given, na? Something is given to us. Look, P is given, V is given. So I need to use PV relation. That is P equals to V square by R. 10 only. Your answer is wrong, not 20. It is 10 only. Look, in physics, whole physics is related. Whole physics. From 11th basic maths to 12th semiconductors, everything is related. It shouldn't be like that you will focus on one and you will lose second one. It is not like that. Okay? It is not like that. Let's suppose we started our class of 12th with electrostatic. When we are studying electrostatic, some portion of electrostatic, why some portion of electrostatic will get repeated in current electricity. Initial part of electricity is now revised here now. Now the electrostatic with electric current, the whole will get revised in what? In capacitor. Then those will get revised into magnetism. Okay. So if you need to be in good physics, don't skip any part. Don't skip any topic. Be consistent every time. Be familiar, and you will get, if you are very familiar with topics, you will get the linkage. Automatically, you will get the linkage. Why? If you do more and more and more practice, eventually you will be the good in physics. Just like your teachers, how they know everything? They are not some different creatures, They have solved 10,000, 20, 50,000 numerical, 1 lakh numerical in their life. That's why they have the idea now. Look, topic is same, Topic doesn't get any modification of topic. Resistance meaning from 10 to 12, it is same. Resistivity is same. Length is same. Area is same. Dependency is same. But what changes, Numerical data changes, nothing else. Okay. Look now, let us do a numerical. And this numerical was asked in NEET. And I will write the language also, so that you will get a familiar to the NEET language also. Done? Two resistors of resistance. No, you need to follow at least 4 to 5,000, no, beta. Two resistors of resistance 100 ohm and 200 ohm are connected in parallel. Okay. The ratio of the thermal energy. The ratio of the thermal energy developed in 100 ohm to that in 200 ohm in a time t is. So this one is my numerical. Done? Then what is given to us? Two resistors. So I will make two resistors. Firstly, how to think about it? Two resistors. One resistor with 100 ohm resistance. One more resistor with 200 ohm resistance. These are connected in parallel. So let's connect them as parallel. Okay, no issue. So we need to find out thermal energy. That means heat, or power. It is power. So I need to write P1 by P2. Look here, sir. Potential difference will be same. So which formula you need to use? Sir, P is equals to V square by R. V is same, so P is inversely proportional to the R. That means P1 by P2 equals to R2 by R1. R2 is 200, R1 is 100, it is 2 is to 1. I guess it will take 15 seconds to get your answer. But it will take only 15 seconds if you are very familiar with the topic. Okay? If you don't know how to deal with it, then I don't know then. Okay? Okay. One more numerical. One more numerical. $18 volt, 4 ohm, 3 ohm, 6 ohm. Done? You need to find out power total. Okay. So for power total, either I need to write I square into R or V square by R. Okay. So I guess we don't need to calculate I, na? No issue. So look, V is given, so I need to write R. So look, 6 is 3. These are in parallel, so I will write 6 into 3 divided by 6 plus 3. This one is series of plus 4. This one is R equivalent. 18 by 9 plus 4. 9 1 9 to the 18. So my R equivalent came out to be 6 ohm. Okay, it is 6 ohm. So if it is 6 ohm, so I will write it V square by R. V is how much? It is 18 into 18 divided by 6. 6 is 1 that 6 is 6 is 18. 8 is 24. It is 54 watt. Sir, please explain the previous one. Which one, beta? Adi, it is which one? 2 is to 1. 2 is to 1? That one? Huh? Okay. I don't think you need any explanation now because I'm not learning anything from it, Anna. So let's start the next part of the power. Did not understand the question. This one, na? This one. This one you don't understand? 54 watt or 2 is to 1? Which one? Just write the answer part, na? 54 watt or 2 is to 1? And I will explain that thing. Advait, hello beta. Long time, huh? No, these are not only NEET PYQs. These are combination of NEET, combination of Ames, IIT, right? JEE Main. These are combination of all these things. As you can see your NEET paper, na, some numericals directly came from your JEE and some easy one from IIT also. So I am giving you, na, I am giving you the idea of solving numericals and the way of thinking how to deal with it. Okay. So I will take this doubt now. Look, we are having two resistors connected in parallel, 100 ohm and 200 ohm. If these two are in parallel, that means the potential will be same V. No issue, beta, no issue. Okay, due to the parallel combination, potential will be same. So I need to get the ratio of P1 is to P2. So which equation I will use? Look, we have P equals to V square by R equals to I square into R. Look, beta, if potential is same, so I will write potential is same. It is constant, na? That P is inversely proportional to the R now. Okay, done, na? So can I write now, sir, P1 is equals to 1 by R1? And what is P2? Sir, P2 equals to 1 divided by R2. Now take the ratio now. So if you take ratio of these ones, so you will write P1 by P2 equals to R2 by R1. And R2 is 200, R1 is 100. You will write it is 2 by 1. But I am. Done? Okay, that's great. Oh, my papers are also starting from tomorrow. Great, beta. Best of luck. Great. Look, in the starting phase of your preparation, I know it is very hard to understand anything in a one go, right? That is great. Best of luck for your paper, beta. Nothing, na. Just sleep well, go examination, whatever is your mind, just write everything, na. But don't skip any question, right? Look now, we'll start bulb. We'll start bulb, right? Okay. Bulb means that we are having in our homes, no? Previously we were had a red bulb, no, with a tungsten filament. Now we are having what? LEDs or we have LEDs, right? Light emitting diode. Look now, this is my some sort of bulb, right? This is representation of my bulb. And when you are just getting the bulb from the market now, when we are buying any bulb from market, two things are written on the cover of the bulb. What's one is power. Power is written. Second one is voltage is written. So power which is written on this bulb known as what? Rated. It is a rated power. Second one is rated voltage. Rated power and rated voltage. That means whenever buying any stuff, any bulb from a market, you were right. You can see now it is 100 watt or 50 watt or 60 watt and 220 volts. So let's suppose it is 220 volt. Second one is that is about 100 watt. This thing means rated voltage. This one is a rated power. Rated voltage and rated power. Done. But what we can do now? Look, with the help of rated voltage, okay, use it for use it. When we are dealing with rated voltage and rated power, we can use it for calculation of resistance. Calculation of resistance. Okay. So for what purpose we need this voltage power and rated power and rated voltage? We can use it to calculate the resistance part. Calculation of resistance. How, sir? Look now. If power is given, voltage is given, what you will write, sir? I guess power is equals to V square by R. So R is equals to V square by P. What is V, sir? It is 100. No, it is not 100. It is 220. No, power is 100. 0 cancel out, 0 cancel out. It is 22 into 22, which will be 484 ohm. This is how we can use it. Done. Look now. But one thing that you need to keep in mind, whenever this bulb is getting manufactured at any industrial point, they have their own voltage system, maintained voltage system, maintained power system. They have their own. No? And at the maximum voltage, that means at particularly 220 volt, your bulb will give full brightness. Okay, so that means if let us suppose we are taking it from any ABC company, In ABC company, exactly 220 volt is supplied. At that particular point, we are saying that it will give a full brightness. It will give full brightness. So I can write here one point, that is supply voltage. Supply voltage means the voltage that is in our homes, supply voltage. If supply voltage is equal to rated voltage, if supply voltage is equal to rated voltage, so you can write, sir, my bulb will give maximum bright. It will be a maximum bright. Okay. If supply voltage, if supply voltage is more than rated voltage, is more than rated voltage, that means we manufactured it up to the 220 volt. But let us suppose with some sort of fluctuation, we got 440 volt. What will happen? My bulb will fuse. It will get burned. Third point, if supply voltage, if supply voltage is less than rated voltage, so I will get dim part. My bulb will be dim, na? You have seen these things in your homes, right? Sometimes when there is low voltage, you will get a dim sort of lighting from your bulb. Why is it help? Why is it getting? No, because due to the functionality of the bulb, we manufactured the bulb at a particular value because we know that at this value it will give full brightness. If we decrease the value, brightness will decrease. If we increase the value, the bulb will fuse. One numerical that we are having, numerical is an yes, an electric bulb is rated 60 watt, 220 volt. The resistance of its filament is. Okay, so sir, first of all, what we need to write now? Look, electric bulb rated 60. It is rated 60, so you will write, sir, power rated is 60 watt. Then this is which one? Fuse means it will burn, na? Everyone is having some limit. So we have tested the bulb. Now we have tested the bulb up to the extreme end. We have we have manufactured the product up to certain end. Then if we increase a point one, it will burn. No? Done. It is 60 watt now. So if we talk about voltage, so V rated voltage rated is how much? 220 volt. We will get a resistance. We will get what? A resistance. So sir, as I told you, P is equals to V square by R. So R I can write it as a V square by P. V is how much? V is 220 into 220 divided by 60. Done. 1 0 cancel out. 2 3 are 6, 2 1 are 2, 2 1 are 2. So we have 220 into 11 by 3. It will be 807 ohm. Easy, no? Easy or super easy? Super easy, no? Okay, one more numerical. One more numerical. We have bulb 100 watt 200 volt. We have a bulb with 100 watt to 100 volt. That means P rated is equals to 100 watt. V rated is 200 volt. It is given to us. This bulb is connected. This bulb is connected to 160 volt supply. 160 volt supply. Then the power consumption we need to study. The power consumption. The power consumption. Okay. So I need to get power consumption. Sir, I guess power consumption would be V square by R. What is V? 160 into 160. R. I guess with the help of these values, I will calculate R because I told you in the first slide, na, this first one bulb. Yes. So what is R now, sir? R is equals to V square by P. What is V? 200 into 200 divided by 100. Cancel out. It is, I guess, 400. My R is how much? 400. It will be 160 into 160 divided by 400. 0 cancel out, 0 cancel out. 4 minus 4 for 16. So P equals to 16 into 4 to 64 ohm, 64 watt. $64. Easy or super easy? Easy or super easy? Huh? Okay. Easy now? Look now. Sometimes no. Sometimes. Bye beta. Bye beta. Look now. As we will be getting some numericals now based on which bulb will get fused and which bulb will not get fused, right? So based on that thing, how we need to deal with those things. Look now. We have two bulbs now. One bulb, one more bulb. If we have two bulbs, right? Two bulbs. 440 volt is we are giving to it. And this first bulb B1 is how much? It is 60 watt and 220 volt. This B2 is equal to 100 watt, 220 volt. Which bulb will fuse? Which bulb will fuse? I guess I have written a statement here. If my supply voltage is more than rated voltage, it gets fused. So you can see here, my supply voltage is 440 and my rated is 220 only. That means both bulb will get fused. Both. B1 as well as B2 will get fused. Done? Okay. One more numerical. Suppose we have a wire with resistance R and it is having 100 watt power rated to 120 volt voltage rated. What is R then? Sir, R will be equals to V square by, sorry, P, yeah. V square is 220 divided by P. What is P? P is 100. Cancel out. So it will become 484 ohm. Next part is, if I will cut it from the middle one, cut. So it will become now R by 2, R by 2. Then I will join these two. Done? Now find power. So what is power now? So power is V square by R. Power is V square by R. If V is same now, it is 220. What is R now? Sir, Look, it is R by 2 and R by 2. My R equivalent will be R by 4. It will be R by 4. So 220 into 220 into 4 by R. R is 484. 4 ones are 4, 4 ones are 4, 4 twos are 8, 4 ones are 4. So we have 220 divided by 121. It will be 400 watt. It is 400 watt. Done. So I will show you now some shortcut tricks or tips. That is, look now, what is power rated? Sir, power rated is equals to V square rated divided by resistance of your bulb. Then, if V is same, if we are having two things same, na? So what do you write, sir? P of bulb, P of rated is inversely proportional of your resistance bulb. Sir, what is the usage of this particular portion? Okay, that is, if we are having two bulb, two separate bulb, P1 40 watt, V1 220 volt, P2 100 watt, V2 220 volt. You need to write a relation between resistance. If this one is R1, R2, which one is more? You can see now, sir, P1 and P2. P1 is less than P2. That means R1 will be more than R2. No calculation, direct answer. Why? Because of this one, no? Easy? Easy or super easy? Next part. First part is combination. If we are combining series combination of your bulb, series combination. If we are having bulb 1, 2, 3, we are having 3 bulb with power P1, P2, P3, voltage V1, V2, V3 and V. So my total power will be inverse of all of them, 1 by P1, 1 by P2 plus 1 by P3. Done. So I can write power total equals to P by N. Identical bulb. If we are having identical bulb, so I will write that relation P by N. In opposite to this one, if we are having parallel combination, 1, 2, if we are combining these three, P1 V1, P2 V2, P3 V3. So you will write P total equals to P1 plus P2 plus P3. If identical, so P will be equals to N times P. P total. Better we have 9 minutes, no? Exactly at 12 o'clock we will end it. Don't worry, no? I'm very punctual. So if we are adding the bulbs, if that's in series, so we have to add them inversely, just like resistor in parallel. Okay. Now if we are dealing with the parallel combination, we have to add them as similar to that of resistance in what? Series. You need to think about it now. Related. Okay. Resistance series, bulb parallel. Resistance parallel, bulb series. Okay. Then one more. Then you will have a capacitor also here, right? Yeah. This one is, look, this one is parallel. It is parallel, na beta? and above one is series. This one is series, and you need to learn about this one, this one, this one, and this one. Okay, take a screenshot, no? Okay. मोटिवेशन होम हेलो, अगर आपसे पढ़ूंगा तो जेई क्लियर है. थैंक यू बेटा. About series 1 series, yes sir. Okay, now let us do a numerical. Okay, now if we are doing something now, then there should be a numerical now for the support. Numerical is, we have three identical bulbs. We have three identical bulbs of 60 watt, and 220 volt. I will take 200 only now for simplicity. 200 only. But I will not tell you now. You can do one thing. You can go with my lectures. If you find these lectures relevant to the JEE, na, you can go through it. There is no issue. You need to check my lecture quality, na. 200 volt. And these are connected in series. These are connected in series. And V supply is equals to 200 volt. Also 200 volt. So what will be the power? Sir, power, series, and identical. So what you will write? 60 by 3. Okay, 20 watt. No usage of this one, no use of this one. Only three identical bulbs series. By these two things, you will get the idea which formula you have to use, no? Second one now. Second numerical. So this one is the last numerical of today's class. Okay, and this is good numerical. Or I will give you homework, right? Homework. And identical bulbs are rated P watt. Are rated P watt and V volt when they are connected in series. Total power consumed is 20 watt, and when connected in parallel, they consume total power of 2000 watt. How many bulbs are used? Okay, so this one is your homework, and tomorrow we will be starting maximum power theorem. Okay, so you can do one thing now. You can do this numerical. In this numerical, the power series and the parallel combination, you will get it very well. Then we will starting maximum power transfer theorem, and we will continue the bulb portion. Okay, then you will have a lot of things. Which bulb will be more bright, which will be less bright, right? Those numericals we will be doing tomorrow. So for today, I guess we have studied more than enough, right? If you have any concern, you can just let me know for 1-2 minutes, then we will just end the class. Bye, beta, and all the best for the paper. So now, 1 second. Okay, so 1 second, beta. Give me 1 second, okay? Okay, I guess you are having now your own private conversation in the chat box, no? Regarding your uh, games. So I will just let you free from the class. Enjoy your life now. Bye, beta. Thank you. Bye. Good night.